next theorem is, which is very important formula, Cauchy integral formula. So what is the statement of this formula? If a function fz is analytic within and on a simple closed contour C, and if z0 is any point in C, then f of z0 is equal to 1 by 2 pi iota integration around C fz over z minus z0 into dz. So this is a Cauchy integral formula. So this integral formula is very useful. Now in order to prove this result, so first proof of the result. Now what is given part? The given part is we have a simple closed contour C, and we suppose the direction is anti-clockwise. So this is some anti-clockwise directions. Now in this simple contour, the given z0 is any point within the C. So that is already given. Z0 is any point within the C. Now we consider a circle which lie in the C, which is a circle which lie in the C with center z0 and radius r. Suppose this radius is r and this circle is called a gamma. So we take a gamma. So what it means? We consider a gamma which is a set of all points inside the circle with center z0 and radius small r. So this is a center z0 is a circle which is a circle with center z0 and radius small r. So this is a circle with center z0 and radius r which does not intersect with the C, which does not intersect with C. It means it lie entirely in the closed contour C. So which does not intersect with C. Then it means, it implies, so just see that the f of z over z minus z0, this is. Now we consider a new function, this, which is a analytic, in this region. So outside the gamma, inside the C, that is a annulus region, analytic within a region, bounded by gamma and C, bounded by C and gamma. So it means, because this function is not analytic only at z0. So when we taken the region outside this z0, so that is this region, for example this region. So at this place, this function is analytic. So this function is analytic in this region, in this domain, in this region. So if it is analytic, then we can apply the Cauchy theorem at this place, that we already proved that. So by Cauchy theorem, So by Cauchy theorem, integration around gamma fz into dz over z minus z naught around C, and integration around gamma, which is circle fz over z minus z naught into dz are equal, and this is denoted as equation number 1. So these are the equal. Now this is by Cauchy theorems, as we did in the previous lectures. Now this integration can be written as this is equal to this values, and this integration can be written as integration around gamma. This fz may be written as f of z minus f of z naught, this is in bracket, plus f of z naught over z minus z naught into dz, this value. So here we add fz naught and subtract fz naught. So this can be written in this way. Now this, if we separate this integration, so we get this is a integration around gamma f of z minus f of z naught over z minus z naught into dz. So in the next term, fz is independent from z naught, z. So this can be written in this way, which is gamma dz over z minus z naught. So this integration can be written in this way. Now suppose I write this is equation number 2. Suppose here my aim is to solve this integration and this integration. So first I will solve this integration. Now given part the function is analytic, then it means it is a continuous. So in the given part, since function f of z is analytic within a simple closed contour within a C, it implies its derivative exists f dash z, it exists in C, it implies this is continuous. So f of z is continuous within C, it implies this fz is continuous at point at z equal to z naught, right? So here we use the differentiability implies continuity. If differentiability implies continuity, then this function is continuous at this point. Now by using the definition of continuity for epsilon greater than 0, these values, there exists a positive number delta greater than 0 such that f of z minus f of z naught less than epsilon for every z minus z naught is less than delta. So this is a definition of continuity. So by definition of continuity, so we get this values. Now from this, here it was equation number 2. So here I write the equation number 3. Now this vector, this element lie in the gamma, if this should be this should be that we can say that choose R, we can say choose R in such a way, in such a way R should be less than delta. It means it is again circle with the radius lambda. So any circle with the radius R lies in this circle. So it means if lies in this circle, then it satisfies this condition. So it means all the element of gamma satisfy this condition. So it means it implies f of z minus f of z naught, this is less than epsilon within gamma. So within all element within gamma. So within all element belongs to gamma. So this condition is satisfied for all element in gamma. So it is also written as the equation number 3. It means when z belongs to gamma, so f of z minus this value is less than this values. So this will be helpful for the first integration. Now for the second integration, also we know that in case of gamma, also we know that z minus z naught, this is equal to radius r on gamma. Also we know that. Then it means this can be written as z minus z naught, which is equal to r into e raised to power iota theta on gamma. So it implies d of z. So this is equal to r iota e raised to power iota theta into d theta, this values. So this is a dz. So dz can be written as iota r e raised to power iota theta into d theta. So this value, so this is again z minus z naught. Now this integration, now dz over z minus z naught, this is around gamma. So this integration can be written in this way, which is equal to dz, which is iota r e raised to power iota theta. Now d theta over, what is the value of z minus z naught? R e raised to power iota theta. And what is the limit? Because theta vary from a 0 to 2 pi. So this is a limit. Now this cancel with this. So what we get? We get this value is equal to 2 pi iota. So this is our result number. So integration dz over z minus z naught around gamma, which is equal to 2 pi iota. So right here it is equation number 4. Now the first integration, in order to solve the first integration, so this is a integration of gamma f of z minus f of z naught over z minus z naught into dz. So this value is less than equal to integration gamma. So this is f of z minus f of z naught over absolute value z minus z naught into absolute value of dz. So remember this. Now by using the definition of continuity, so this is less than epsilon. So this first is less than epsilon, and this is integration gamma modulus of z over modulus of z minus z naught. So we know that the modulus of this is a epsilon. So integration around gamma. So what is the modulus of z minus z naught? So as we know that z minus z naught is equal to r e the iota theta when we take modulus. So its value is equal to r. So here this is equal to r. Now what is the d of z? So this is a r e iota theta, iota into d theta. So this is again this value when we take the modulus. So this will be 1 modulus of iota 1. So this is again r into d theta. So this is an absolute value of d theta. So this is when we take theta is varying from 0 to 2 pi. So this value will become 0 to 2 pi. So this will become a 2 pi epsilon. So this is a value of the integration. This is less than this values. Now from this what we get, when since epsilon greater than 0 is arbitrary, since epsilon greater than 0 be arbitrary, so as epsilon approaches to 0 arbitrary, so as epsilon approaches to 0, so this approaches to 0 as epsilon approaches to 0. So integration of it implies integration of fz minus fz naught over z minus z naught into dz around gamma is equal to 0. So this is some equation. So when we substitute these value in the equation number 3, so what we get? So we get integration of fz dz over z minus z naught around c. So this is equal to, as we divide it, so first integration is 0, and what is the value of second integration? So this is equal to f of z naught integration of fz over z minus z naught around the gamma. Now what is its value? So its value is 2 pi iota. So we solve that. So this is equal to 2 pi iota f of z naught. So from this we get our result. So what is that result? That result is f of z naught, which is equal to 1 by 2 pi iota integration of f of z into dz over z minus z naught. So this is the value of integration. So this is our result. So this is a Cauchy formula. So this is very important result. So in this Cauchy integral formula, we can find the value of function at some point z naught, which lies inside the circle, inside the simple closed contour. Now after that, the next result is related to this, which is called Gauss-Mean values theorem. So again it is very important. So this is Gauss-Mean value theorem. Gauss-Mean value theorem. So what is the statement of this theorem? the statement of this result is, if a function fz if a function fz analytic in a domain D and if the domain circular domain gamma, which is z minus z naught less than equal to rho, we can also use r. So in domain D, so this is a circle which lies in domain D. Then prove that f of z naught, which is equal to 1 by 2 pi integration 0 to 2 pi f of z naught plus rho e raised to power iota theta into d theta. So this is this values. Also we can say that the statement can be written as value of fz at point z equal to z0. So what is this? It is a value of fz at point z equal to z0. So this is equal to, so what is this? This is average value. What is this? Which is a average value, the average of its value, average value of the boundary of the circle, boundary of the circle. So what is this? It is a average value on the boundary of the circle. So we take the value at the boundary, then what is its average value? So that is equal to value of function fz at z equal to z naught. So this is very important concept. So this is called a mean values theorem, Gauss mean values theorem. So first understand the statement. So what is the given part? So given part is, if we have some domain D, suppose this is some domain D, right? And here this point is z naught, which lies inside the domain. If it lies inside the domain, and this is a, suppose, circle whose radius is rho. So this is a gamma circle whose radius is rho. This values. Now if this values, then what is the value of function at this point, at the point z naught? This value is the value of function on the boundary of gamma, right? The average value of the function on the boundary of gamma. So we take the value at each point, then taking the average, that is equal to the functional value of fz at the point z naught. So this is a basically Gauss mean value theorem. So just remember that. Now, in order to prove this result, so we will use the Cauchy integral formula. So by previous, what is Cauchy integral formula? So by Cauchy integral formula, also we can say that it is a Cauchy integral theorem या Cauchy integral formula. So by that result, f of z naught, which is equal to 1 by 2 pi iota around this. So here it is gamma f of z over z minus z naught into dz. So that is by using Cauchy formula. So first this is around C, then after that it is around gamma. So just first in order to just this is a theorem. So here I get the this statement. So just so before going to the Cauchy integral formula, so we here prove that the integration around that is equal to this values. So f of z is equal to this. Then by Cauchy integral formula, so we write it as f of z equal to this values gamma. Now in this case, now what is the z minus z naught? Because gamma is a circle with center this. So z minus z naught is equal to rho. So it implies z minus z naught, which is equal to rho into e raised to power iota theta. It implies from this z is equal to z naught plus rho into e raised to power iota theta. So first find this values. Now what is the dz? So we can find it from this values, which is a rho e raised to power iota theta into iota into d theta. So this value. Now substitute all these value in this equation. So this equation is suppose equation number 1. So what we get? We get here f of z naught, this value. So this is equal to 1 by 2 pi iota, and this is around gamma. So we will change the limit after that. So f of what is the value of z? So this is a z naught plus rho e raised to power iota theta. This values. And what is z minus z naught? So this is a rho e raised to power iota theta. And what is dz? So this is a rho e raised to power iota theta into iota into d theta. So this term cancel with this term, this iota is cancelled with this iota, and limit will be 0 to 2 pi, this values. Now from this what we get in order to simplify this result, so this we directly get the value of Gauss's mean value theorem 1 by 2 pi, so which is 0 to 2 pi, and this value is f of z naught plus rho e raised to power iota theta into d theta. So which prove our result. So this is f z naught, which is equal to 1 by 2 pi integration 0 to 2 pi f of z naught plus rho e raised to power iota theta into d theta. So which prove our result. So that is our result, that is a Gauss's mean value theorem. So this is very important theorem. Now next result is using Cauchy integral formula. So next is using Cauchy integral formula. Cauchy integral formula. This is Cauchy integral formula to find the first derivative find the first derivative of an analytic function. Analytic function of the analytic function fz at point z equal to z naught, at the point z equal to z naught. So use Cauchy integral formula to find the first derivative at this point. So this will be f dash z naught, which is equal to 1 by 2 pi iota around integration fz dz over z minus z naught, right? So similarly, we can find the second derivative, third derivative, fourth derivative, and so on. So in this way, we can find the higher order derivative. Now, the proof of this result, this theorem. So in order to prove this result, so first by Cauchy integral formula, by Cauchy integral formula. So first understand the Cauchy integral formula. So what is the Cauchy integral formula? The statement is f of z naught, which is equal to 1 by 2 pi iota integration around c f z dz over z minus z naught. So I write it equation number 1. So here all the condition of Cauchy integral formula is satisfied. It means it is analytic within a simple closed contour and z naught is any point inside the C. So all conditions are satisfied. Now assume, let z naught plus h. So this is any point in the neighborhood of z naught. So this is be any point in the neighborhood of z naught. So this is some point in the neighborhood of z naught. So just replace z naught by z naught plus h. So we get f of z naught plus h, which is equal to 1 by 2 pi iota integration c f of z into dz over z minus z naught plus h. So which is the equation number 2. So this is equation number 2. Now, So in the next step, so now f of z naught plus h minus f of z naught, so which is equal to 1 by 2 pi iota common integration c, and this is fz bracket 1 over z minus z naught plus h minus 1 over z minus z naught bracket band, so into dz. So this values into dz. Now simplify. What is this? This is z minus z naught minus h. So simplify this integration. This will become 1 by 2 pi iota integration around c. So this is in bracket over z minus z naught minus h z minus z naught into fz into dz, and here z minus z naught minus z plus z naught and plus h, this values. So this z, this minus z naught, so this cancel with this term, so this is a h. So remaining this part is h over this values. So it implies in the next step, it implies this is equal to 1 by 2 pi iota integration around c h fz dz over z minus z naught minus h into z minus z naught, this values. Now when we divide by h on both sides, so what we get f of z minus f of z naught over, here it is f of z naught plus h. So just first I write it in a proper way. So this is f of z naught plus h minus f of z naught over h. So this value is equal to 1 by 2 pi iota integration c, this h cancel. So f of z into dz over z minus z naught minus h into z minus z naught, this values. Now what is this values? Now taking limit on both sides, limit h approaches 0. So here limit h approaches 0. So what we see that this is a derivative of function at point z naught, and this value is equal to 1 by 2 pi iota integration c, here fz into dz, since z approaches to 0, so this will become a z minus z naught. So thus this total will become a z minus z naught raised to power 2. So this is our result. So it is a derivative of function at the point z naught. This is a derivative of the function at the point z naught. So in this way we can use the Cauchy integral formula to find the derivative of the function at the point z naught. So just remember that in this case, here it is power 2. So just remember it is not single power, it is power 2. So f dash z naught, which is equal to 1 by 2 pi iota around integration c f z dz over z minus z naught raised to power 2. So in the next lecture, we will prove the derivative of higher order. So that formula is, so just remember that this is nth derivative of function at point z naught, so which is equal to n factorial over 2 pi iota. So this is integration around c, which is fz dz over z minus z naught raised to power n plus 1. So we will prove in the next lecture. So what is the higher order derivative of a function at the point z naught? So even from this result we can find the first derivative, second derivative and third derivative. So just remember this formula. So remember that this formula is very important. So this is a nth derivative of function at point z naught, which is equal to n factorial over 2 pi iota integration fz over z minus z naught raised to power n plus 1. So that is our result.